Today we'll be dealing with ordinary differential equations. Our business for today under this ordinary differential equations is separable equations. Now, like separable equations tells us, it means it is an equation that will get to a place and then separate those variables in that equation. Now, solving for separable equations for this question we have here, the y dx is equals to xy. This means we are going to separate the x variables from the y variables. Therefore, we will be dividing both sides by y and dividing this by y. We would have this to be dy dx y equals to x, because y cancels y. Now from here we would also separate this x we have here by dividing both sides by the x, dividing here by the x. Therefore this, by multiplying both sides by the x, and multiplying here by the x cancels out. We have the y over y is equals to x dx. Now from here, what we'll do, the next step after separating the variables for separable equations is actually to integrate this place we have here, this equation we have here. We will integrate this both sides. Therefore, we will have here to be natural logarithm of y, because differentiating this natural logarithm takes us to this. Therefore, integrating it, we are reversing that derivative we made. Now, integrating this, we would have x squared over 2 plus c. From here, we would say, we would raise both of them to an exponent. Exponent of the natural logarithm of y is equals to the exponent of x squared over 2 plus c. This natural logarithm has a base of e. The e cancels out, therefore we are left with y on this side. Now, one fun part about this we have here is we can separate this to be exponent of this alone and exponent of this alone. Because from indices we are told that e to the power of a plus b is equals to e to the power of a times e to the power of b. Therefore, we can as well separate this to have e to the power of x squared over 2 times e to the power of c. From here we say y is equals to e to the power of x squared over 2. Now this exponent of this constant becomes a constant, because the exponent of a constant gives us a constant. Now we'll be substituting e to the power of c for c1, a new constant, which is the exponent of the former constant we had. Therefore we'll do this as c1. Y is equals to c1 exponent of x squared over 2. Now this is the general solution for this equation we have here. If we are asked to find the particular solution or answer for y here, this constant will become 0. Therefore we'll have y is equals to 0 on this side. Therefore this is the particular solution and then the general solution.